Sorry about that. I didn't think that it would go over time, but this is part 2 of the expected value quiz review, and we are currently on question 6. If you haven't seen my explanations for the previous questions, then please go to the part 1 video. And so where we left off, since this is without replacement, this means that as one ticket is drawn, we are left with one less ticket, and we are eventually on the third ticket, about to draw the third ticket. So we have 28 total tickets left. So our probability is 1 out of 28, but we multiply that by the value of the ticket, which is 30, times 1 out of 28. And we get, our expected value is 6.13, or $6.13. So this means that every time we get a ticket, we have an average expected profit of $6.13. So if your neighbor offered to buy your ticket before drawing, what would be a fair price? Well, again, a fair price is just that nobody loses or gains anything. Neither side loses or gains. So if he pays you the same amount that you were expected to get, then it's a fair price. So the fair price your neighbor has to pay is $6.13. But of course you could tell him, you have to pay me, for example, $10 so that you can make a profit. A company believes it has a 40% chance of being successful on bidding a contract that yields a profit of $30,000. Assume it costs $5,000 in consultant fees to prepare the bid. What is the expected gain or loss for the company if it decides to bid on the contract? So one thing that you guys shouldn't be confused or misunderstood by is if it decides to bid on the contract. In this case, in the problem, we aren't considering whether they decide on it or not. It's if they decide. So always they're going to decide to bid on the contract. So they're always going to pay $5,000. So they're always going to give out $5,000 or lose $5,000. Now, the probability of them getting a profit or successful on bidding a contract, which has a profit of $30,000, is 0.4. You multiply that by the profit, and that is $30,000. And our expected value is $7,000. So the company, each time, or if it decides to bid on the contract, it will have an expected gain of $7,000. So the company should definitely bid on this contract. Because they will almost always get a profit. The world-famous gambler from Philadelphia, Senor Rick, proposes the following game of chance. You roll a fair die. If you roll a 1, then Senor Rick pays you $25. If you roll a 2, Senor Rick pays you $5. If you roll a 3, you win nothing. If you roll a 4 or 5, you must pay Senor Rick $10. And if you roll a 6, you must pay Senor Rick $15. Is Senor Rick loco for proposing such a game? Explain. So first we have to calculate the expected value, the expected loss or gain of playing this game. So in order to do that, we know that a die has 6 sides, normal. It's a normal die. So the probability of us rolling a 1 and getting $25 is 1 out of 6. We multiply that by $25 plus the probability of us rolling a 2 is also 1 out of 6. Since this is a fair die, this means that all the probabilities should be equal. So all of them should be 1 out of 6. And we'll get $5 if we roll a 2. And if we roll a 3, we get nothing. So basically 0. And if you roll a 4 or a 5, you must pay Senor Rick $10. So you lose $10. So it's a negative 10 times the probability of us getting a 4 or a 5. Well, this is basically 1/6. The probability of getting a 4 plus the probability of getting a 5. 1/6 plus 1/6. You could do that together separately, but I'm going to do it together just to make it more simple. Since 1/6 plus 1/6 equals 2 out of 6, and that simplifies to 1 out of 3. And if we roll a 6, that's all just a 1 out of 6 chance. We have to pay Senior Rick $15, so we lose $15. We pay Senior Rick $15 times 1 out of 6. The expected value is, it is negative 0.83 cents. So basically, every time you play Senior Rick's game, you are expected to lose 83 cents. So you're going to pay, even though you don't pay him anything in the beginning, you're going to lose 83 cents because you might pay him $10 or $15 if you roll a 4, 5, or a 6. So Senior Rick is not loco for proposing a game. This game is not crazy. He's not crazy for proposing this game because each player that plays this will, on average, bring him a profit of 83 cents. For him, it's a profit, but for us, it's a loss. Question 9. A manufacturer is considering the manufacture of a new and better mousetrap. She estimates the probability that the new mousetrap is successful is 3 out of 4. If it is successful, it would generate profits of $120,000. The development costs for the mousetrap are $98,000. Should the manufacturer proceed with plans for the new mousetrap? Why or why not? So in order to say if she should proceed with the plans, we'll see if she gets an expected gain or an expected loss. Of course, if you are losing when you're investing in something, you don't want to invest in it. So the development costs for the mousetrap are $98,000. She's always going to pay $98,000. She's not going to pay any more, any less. So it is $98,000 loss for her in the beginning. Who knows what she might gain? And the probability of the new mousetrap being successful is 3 out of 4, which is basically 0.75. We multiply that by the value. She'll get a profit of $120,000, which is the value associated with 0.75. And the expected value is, boo, it's negative $8,000. This means that every time, or if she invests in this new mousetrap, she'll be on average expected to lose $8,000. So she should not proceed. The manufacturer should not proceed with the plans for the new mousetrap. Sorry about this, my typing. New mousetrap because she is expected to have a loss of $8,000 for that mousetrap. A grab bag contains 12 packages worth 80 cents apiece, 15 packages worth 40 cents apiece, and 25 packages worth 30 cents apiece. Is it worthwhile to pay 50 cents for the privilege of picking one of the packages at random? So we are going to find if it's worthwhile, then you're going to have an expected gain. You're going to get back more money than 50 cents, which will pay back for your 50 cents. But if it's not worthwhile, then you're going to actually lose money. So no matter if we pick any package, no matter what package we pick, we will always pay 50 cents, negative 0.5, in order to pick one of the packages first. And we are picking only one of the packages, so we don't care about this number 12 necessarily when we actually do care about it. But first we're going to find the total number of packages, which is 12 plus 15 plus 25, and this adds up to 27 plus 25 is 52 packages total. And we are going to calculate the probability of getting 12 packages, which are worth 80 cents a piece. And probability of that is 12 out of 52. And we multiply that by the value, 0.8, which is 80 cents, plus 15 out of 52 times value associated with that, which is 40 cents a piece, 0.4, plus 25 out of 52 times the value, which is 0.3, and the expected value is approximately negative 0.06 cents. So each time you pick a package at random and you pay 50 cents to pick that package, you're gonna most likely lose 6 cents. So you definitely shouldn't try this bet. It is definitely not worthwhile. And the last question, you pay $10 to play the following game of chance. There is a bag containing 12 balls, 5 are red, 3 are green, and the rest are yellow. You are to draw one ball from the bag. You will win $14 if you draw a red ball, and you will win $12 if you draw a yellow ball. How much do you expect to win or lose if you play this game 100 times? So in order to find the expected gain or loss if we play 100 times, we first need to find the expected gain or loss if we play one time and we multiply that by 100. So no matter, the first step is always you pay $10. No matter what, you're always going to lose $10, negative 10. Plus, we have to find, well, they give us the total number of balls. So there are 5 red, 3 are green, and the rest are yellow. Well, how many are yellow? It's 12 minus 5 plus 3, which is 4. 4 are yellow. The probability, if you draw a red ball and you get $14, is the number of red balls are 5. So 5 out of 12 times $14 plus the probability that you draw a yellow ball, again, is 4. 4 out of 12, which is basically 1/3. You could reduce this if you want. You would get $12 for that, and our expected value is negative 0.166, which is basically approximately 17 cents we lose each time we play this game. So if we play 100 times, we're going to multiply this by 100 to get that expected gain or loss, which in this case it's a loss because we're losing. And we will get a value of negative $16.67. And we definitely do not want to play this game. So thank you guys so much for watching. This is all I have for today. And if you like this video, please like it and subscribe to my channel.